Here we go. Let's just grind right through this. First set of notes. Now, you don't have to write down everything and or draw the picture. You just need to know the important facts. Important facts. If two lines are on the same plane and will never touch each other, running right alongside each other, then they are called parallel lines. Parallel. Now, why is it important to say that they need to be on the same plane? It's kind of a three-dimensional question, so I'll be impressed with them to get. Yes, sir. Oh, I got it. You know, I think you're actually thinking above the lesson. I don't even know what you're talking about, but it sounds like it's really fun. Yes, sir.
Because if they're not on the same plane, they won't be beside each other.
Well, actually, you're half right. They won't be beside each other. So we can agree these will never intersect, right? They don't have to be running right alongside each other to never intersect if they're not on the same plane. For instance, take this line right here in the ceiling, right? It's going right down here. This line right here is parallel to it because they're on the same plane and they'll never touch. But will this line ever touch that crack in the corner going vertically? No. This line and this line will never touch. But you can see they're definitely not parallel. But they'll never touch because they're not on the same plane. Two lines that are not on the same plane like this and will never intersect. See how these will never intersect? Those are called skew lines. Skew lines are two lines that never intersect but are not coplanar. So there's the big difference there. Parallel means they're running right alongside each other in space on a plane. Skew, means they have nothing to do with each other, but they'll never touch. If two lines are well, I'll get that. What? Okay. Two planes can also be parallel. This blue and this green plane here are parallel planes. They'll never touch. You can't have skew planes because since they're three-dimensional, you shift those in any way and they'll touch them. So planes are either parallel or not parallel. So this is the symbol for parallel. M is parallel to N. And in your book, it'll be denoted by arrows in the middle of the lines. The different number of arrows. There might be 20 different lines. How do you know which ones are parallel? It's the number of arrows. These two might have one arrow. These two might have two little red arrows. The ones with the same number of arrows are parallel. Questions? People writing, so I'll give you a second. Yes, sir. Yep. Sure, but it would also have to be going vertically. Really, if you think of it, see, remember I was talking earlier about you have to think about what could be? Kind of deep of a concept, but really every line goes through instantly many planes. You could think of plane, and these are just slicing through all of them. So these two would be skew lines because they never touch and they're not coplanar. And even though you probably aren't going to need to know this, it's probably helpful to know these two are technically coplanar, right? Because could I theoretically slice a plane straight vertically that would go through both of those? Yeah, if you have two lines, you could slide a plane through them that would have both of them. So geometry is a very three-dimensional concept, but we're only going to talk about the more basic stuff. All right, here's the picture. Line CD is parallel to what other line that contains point A? There's lots of answers that are parallel, but which one contains point A? What's that? Very good. Line AB. contains point A and runs parallel, and they share a common plane, which would be that top part. Very good. What about a line skewed to CD and containing point A? What's that? CD, skew, containing A. So what did you say was? AG would be one. AH would be one. Very good. And technically, you could be like AE, AF. All those would technically be right. They're not drawn. That doesn't mean they're not there. FA would be coming out this way through A and never touch it. AG, AH, all those. Pretty much the only thing you could have said that would have been wrong is AB. Because that's parallel. Now, perpendicular we haven't talked about yet, but what a line perpendicular means it forms a perfect right angle and is coplanar. So, what line is perpendicular to CD and contains point A? They will cross at a right angle. Yes, sir. AB is parallel to CD. AD is perpendicular to CD, hence the right angle. Perpendicular means forms a 90-degree right angle. D, plane parallel to EFG. Where's EFG? That's right, it's the bottom. What's a plane parallel to EFG containing point A? You got this one? Oh, Justin, you go. What was it? Very good, the top. The top is parallel to the bottom. DAB or DCA or DAC, however you want to word that plane. Good, very good. Questions? All right. We're going to look at these and answer them, but I'm going to give you a moment. I'm going to give you a moment to look at them, and then we'll discuss. And I'll pick people to answer said questions. Cameron, DE and CF, what are they? That's exactly what they are. Did anybody get something other than skew? Okay. Let's see. Number 2, Rachel, what do you think? AD, BE, and CF are all what? Very good. They are all parallel. No, they're not. Yeah. These two are parallel, these two are parallel, and those two are parallel. Number 3, plane ABC is what with point? Elijah, what do you think? Number 3. Very good. That's kind of the back over here and the front, and those two planes are parallel. Very good. Number 4. Stacy. BE and AB. What's that? BE, well, here's a hint. If they ever share a common point, that means they have to intersect at that point. That's right. Now, technically, this is a flawed question. What am I always telling you? You can't assume. How can we just assume that this right here is a right angle, or BE meets AB? We can't. But since they only gave us 3 options, and 2 of them by definition never touch each other, they had to be perpendicular. But shame on them for not putting the right angle in there. Question. All right, you do not have to record these. This is just a thinking point. Okay? Now, let me provide an example. What it says is, here's a line, here's a point. How many lines can I draw through that point that would be parallel to this one? How many lines can I draw through this point that are parallel to that one? Only one. And here's why. You draw that line, like, hey, that's the parallel one. If you turn that line even slightly, then eventually these two will intersect. So the angle is so important. So there's only one line that you can draw through a given point that'll be parallel to another line, and by the same principle, perpendicular, because if you turn it ever so slightly, this will no longer be 90 degrees. You don't have to record those, but it's just helpful to know that it might be a test question. How many lines can you draw through a point that will be parallel or perpendicular? One. Okay. All right. Now we're going to get down into the meat of today's lesson. First of all, when you have two lines that are sliced by a common line, that line is called a transversal. That'll be a helpful thing for you to know because you're about to see the word transversal a lot. Transversal will be the line slicing the other two. The next four slides are all talking about different pairs of angles. Okay? On this one, it's these two. The next one, it'll be like these two, and then these two, and then there's all different kinds of angles formed here. Now, before we talk about the specific ones mentioned in this problem, this is something you need to know. If I were to cover this up, we would just have one intersection, right? We've talked about two kinds of angles that are formed by just one intersection. Does anybody remember what they are? Yes, sir. They are collinear, but, I mean, there were two types of specific angles, like they had names. Yes, sir. They are. Any angles are acute and obtuse, but, I mean, so many. I think you said one of them. Linear pair was one, and what was the other? Linear pair, and the other was vertical. You can take any two problems off your homework today. Very good. A linear pair was any neighboring angle, like these two, these two, these two. Those were linear. Vertical were opposite of each other. Now, why am I telling you this now? Because you're still going to need to know those. What you need to remember is that vertical and linear are just one intersection, and the other things we're doing today require two intersections. First thing we're going to look at is corresponding angles. Corresponding means they have the same location, which means, couldn't you describe both of these as the top right angle? Therefore, they are corresponding. These two would be corresponding because they're both the top left angle. These two would be corresponding because they're the bottom left angle. And these two would be corresponding because they're the bottom right angle. So there's always going to be four sets of corresponding angles for every intersection like that. Question about what it's referring to when I say corresponding. The next three slides are all the same exact picture with different types of angles. These are called alternate interior angles. And if you use context clues, you can probably figure out why they're called that. Notice how they're on the interior of the intersection. They're both on the inside. That's right. And they're on alternate side of the transversal. So 4 and 5. And then these two angles would be alternate interior as well. Questions about those? Yes, sir. Okay. The majority of your assignment today, in fact, I'm even going to, maybe even all of it, I don't remember exactly, it's just, here's some angles, what are they? And you're going to feel like, oh, those are alternate exterior angles. Because I'm going to be teaching you more stuff about them in the next days, but you need to know where they are first. So here's a question. Let's see if you can get this one. If these are alternate interior, what do you think these would be called? Alternate exterior. Very good, and I believe that's our next one. Alternate exterior. If they're on alternate sides and opposite of the transversal, they're alternate exterior. There will be two sets of them, 1 and 8, and these two would also be alternate exterior. You could just draw a diagram and label them if you wanted to, rather than write down all the words, but that's completely up to you if you choose to do that. And the last one is consecutive interior. They're on the interior, but instead of alternate sides of the transversal, they're on the same side. They're also actually known as, they're not here, but they're actually also known as same side angles, I believe. But you don't have to write that. Consecutive interior angles, they're right next to each other. Now, here's where people get these things mixed up. They'll look at, like, in a minute, there's going to be 8 numbers up here. Like 1, 2, 3, 4, 5, 6, 7, 8. And you're going to have to pick out the 2 numbers that are this and that, and all 2's interior, etc. And a lot of people are like, consecutive interior. These 2 would be. No. These are a linear pair. If you can completely cover up the other intersection and talk about 2 angles, then they're not anything we're talking about today. You have to have an angle on both intersections for it to be something we're talking about today. I'll be impressed because I don't know what it is. You know, surprisingly, there's not one of those. I don't know why there's not. It makes sense that there would be, but there's not. Okay. A. There's 4 pairs of corresponding angles. Who can raise your hand and tell me what those 4 pairs would be? Actually, I'm not going to ask. I'm going to pick somebody. That's what I'm going to do. Who I want to pick on? Miss Smothers. Where are my corresponding angles in this picture? Two and 6. Very good. They're both the top right. You said 4 and 8. And what are the other 2 pairs? Rachel? 3 and 7. And what's the last one? Very good. Very, very good. Those are the corresponding angles. Questions? Alternate interior. Elon, what do you think? Where are my alternate interior angles in this picture? And? Close. 2 and 7, but instead of 6 and 4, it's 5 and 4. On the inside, the interior of this. Very good. Alternate exterior. Very good. 1 and 8, and 3 and 6. Question? Yes, sir? Or you volunteer for the next one? All right, take it. Consecutive interior. Very good. Quick rehash of past vocabulary. Who can tell me just 1 pair of linear pair in this picture? Yes, sir. 4 and 2 would be a linear pair. What about 1 pair of vertical angles in this picture? 1 and 4 or 3 and 2. Very good. It's always good to keep fresh vocabulary from the past because you're going to need it. All right. I'm just going to point and you tell me what kind of angles they are. Rebecca, what's number 3? I believe in you. What is answer? Would you like to phone a friend? I'll come back to you in just a moment. Cameron, what is number 3? It would be corresponding. If you can classify them both as the same location, they're both top left, then they're corresponding. Justin, why don't you try number 4? Alternate exterior, very good. Becca, can you get number 5? Alternate interior, very good. That's the end of the lesson. I told you it's all vocab. Are there questions about anything we've done before I give you your assignment? Yes, ma'am. Yes. You're right. They're not technically the same. They're just in the same location. Yeah. They might not be the same measure. But I'm glad you're thinking like that because tomorrow's lesson I'm going to be showing you ways to know if they're the same. So you're on the right wavelength. Today it's just all about identifying what they are. There you go. Don't forget to put your student number at the top.